Section 4 is going to take our circle material to a couple of different places to really extend and deepen your knowledge. So first we're going to look at what does the equation of a circle really mean. And so if you remember back to our definition of a circle, it was the set of all points equidistant from a given point. And those equidistant points, we know that's all a radius. Now, an equation is really the recipe, it's the directions for finding every single to infinity set of xy's that are on this circle. So if we are going to test a point, if it ends up being equal to the radius squared, we know that it is on the circle. If the sum is greater than the radius squared, it's going to end up somewhere outside of the circle. And if the sum is less than the radius squared, it's going to end up somewhere inside the circle. And if you think about that, that should feel pretty solid common sense. So now it's just a substitute and solve situation. So does 2 minus 1, the quantity squared, plus 4 plus 1, the quantity squared, how does that relate to 16? Is it going to be equal, greater than, or less than? And so I have 1 squared plus 5 squared. Obviously, I'm going to end up with 26. That's greater than 16. And that means that this one is somewhere outside of my circle, whose center is at 1, -1, and who has a radius of 4. So that point's somewhere out there. If you look at the next one, 2 minus 1, the quantity squared, plus 2 plus 1, the quantity squared. How does that compare to 16? Well, I have 1 squared plus 3 squared, and so I have 1 plus 9. Well, 10 is less than 16, and so 2 is somewhere inside of my circle. And so then if we test our last one, we have 1 minus 1, the quantity squared, plus 3 plus 1, the quantity squared. How does that relate? Well, I have 0 squared plus 4 squared is clearly equal to 16. This one is on my circle. And if we think about where, 1, 3 might be somewhere like right there. So that is how we determine if things are in, on, or outside of a circle. So pretty straightforward. Now, circles and tangent lines is really going to extend our knowledge even more so. So if we think about that circle and then that line tangent, we should be able to come up with the equation of that line. And remember, our base equation for lines are y equals mx plus b. So we would have our equation for our circle, and we'd have equation for the line, and it's all going to hinge upon that point right there is both going to be a point on our circle and a point on our line. Additionally, we know that my radius and my line are perpendicular, and so we know that our slopes are going to have to be opposite reciprocals. Now, one more blast from the past is, remember, we have another equation beside this one, and it was called the point slope form. And remember, that was y minus y1 is equal to m times x minus x1, where x1, y1 is a point on, and m is your slope. And this is going to be the formula we are going to use to write our equation, because again, we're going to know a point, and we're going to know that slope. So, just to review, we are going to get an icky formula that we are going to have to use completing the square on. Once we have completing the square, we are going to know our center. We know this point on, so we will be able to figure out our slope of our radius, which will then give us the slope of our tangent line, with a point on that tangent line into this equation. Big rough idea, so let's back up and go through this again. So, remember when we complete the square, we put our x's and our y's together, leaving that blank, and we move the constant to the other side, leaving 2 blanks. So half of 2 is 1, square it and add it to both sides. Half of 4 is 2, square it, add it to both sides. So my equation of my circle is this, and I'm equal to 45. So now we have a center of -1, -2, and a radius of the square root of 45. So we're going to need, I'm going to jump over to some clean space because we're going to need a little bit more room to do this problem. So again, our center is at -1, -2. My radius is equal to the square root of 45, and we're tangent at the point 5, 1. So let's just sketch, just super rough. 1, 1, 2. Here's my center right here. I'm going to at 1, 2, 3, 4, 5, 1. That's where we're going to touch. So my circle looks something like yay. Here's the radius that we are looking at. So right now we need to find the slope of the radius. And we're going to do that because the slope of that tangent line that we're trying to find the equation of is the opposite reciprocal. So we are going to calculate the slope between this point and this point. And so my slope is going to be equal to -2 minus 1 over -1 minus 5, -3 over -6, positive 1/2. Once I know that slope, that means my slope of my tangent is going to be -2 over 1. And once I know the slope of my tangent and a point on, I'm going to use the point slope to write the equation. Now remember, point slope is y minus y1 equal to m times x minus x1. So substitute in what you know. I know my point on, and remember I'm going to use that 5, 1, and so I've got y minus 1 is equal to my slope, -2 over 1 times x minus 5. Make sure you use the 5, 1. Make sure you use the point on the line that we're trying to write the equation for. Distributive property at the back, y minus 1 is equal to -2x plus 10. If you want to go ahead and put it into slope-intercept, add 1 to both sides, and y is equal to -2x plus 11. It has a y-intercept of 11 with a slope of -2. So that equation is the equation of that line, which is tangent to that circle at that point. So it's a pretty cool combination of your algebra and your geometry. So let's look at the second example. So similar sort of problem. Circle has this equation, passes through point P. Given that the tangent to the circle at P passes through a different point, find the length of PQ. This one definitely requires a picture, and I'm going to continue it in the next video.